Hello, in this video, we'll be looking at topic 1.12 on transformations of functions. The learning objective is to construct a function that's an additive and/or multiplicative transformation of another function. A really important aspect of understanding functions is the concept of transformations. You've done transformations in previous courses. You might remember that the values of a, h, and k affect the graph of the parent function. Well, throughout this course, we're going to study a variety of functions and their graph, and all of these functions can be viewed through the perspective of transformations. Transformations are going to weave through everything we do in AP Pre-Calculus, and they're going to provide a way for us to connect the different topics we learn. There are 4 different types of transformations that we can do to functions. The first is a vertical translation. The general form of a vertical translation is g of x is equal to f of x plus k. And we say that f has a vertical translation of k units. In our example here, g of x equals f of x minus 2. So we could say that f has a vertical translation of -2 units. With vertical translations, the translation is exactly what you would think. A positive k is going to move it up 2 in the y direction, and a negative k, like this example here, -2, moved it down 2 in the y direction. Horizontal translations are actually going to be the opposite of what they look like in the parentheses. Notice that for a horizontal translation, the x is affected. So you're going to see a horizontal transformation happen in the parentheses with the x. Here we say that f has a horizontal translation of opposite of h units, -h. So here, if I see f of x plus 2, it actually has a horizontal translation of the opposite of 2, so horizontal translation of -2 units. You could also say that it has a horizontal translation 2 units to the left. Next, we have vertical dilations. A vertical dilation is going to occur when the function value is multiplied by a constant. So that a value is outside my function, and we say that f has a vertical dilation by a factor of the absolute value of a units. That just means if this were like a -2, we would say that f has a vertical dilation of a factor of 2, and then the negative ends up being a reflection over the x-axis. So in our example here, g of x equals -2 f of x, we would say that f of x has a vertical dilation of 2 units and is reflected over the x-axis. And then lastly, we have a horizontal dilation, and a horizontal dilation affects the x. So notice, like with these two here, the horizontal translations and the horizontal dilations, they're going to be like the opposite of what you see in the parentheses. So here, if my b value in the parentheses is there, the horizontal dilation is going to be by a factor of 1 over b. That just means whatever the fraction is, we flip it. If I see a 2 in the parentheses, f of 2x, that would be a horizontal dilation by a factor of 1 over 2 units. If the value of b is less than 0, in other words, if b is a negative number, f is going to be reflected over the y-axis. This chart just has a few helpful hints and tips on transformations. Any transformation that affects the x values is always going to occur inside the parentheses with the x variable. And we saw that with the horizontal translation and with the horizontal dilation. Any transformation of the x values is going to do the opposite of what it looks like to the x values. So you're either going to flip the sign if it's a horizontal translation, or if it's a dilation, you're going to do the reciprocal. And then any transformation that affects the y values is going to occur outside of the parentheses, and it's going to do exactly what it looks like to the y values. For our first example, let g be a function that's a transformation of another function f such that g of x equals 2 times f of x minus 3 plus 1. Let's describe the transformations of the function f that will result in the function g. You want to start inside the parentheses with the x value. So that's what I'm going to do first. So remember that when it's in the parentheses with the x, it's the opposite of what you see. So if I see an x minus 3, that's actually a plus 3. Okay, so I'm going to state that the function f is horizontally translated three units. And if you'd like to state a direction, you can say 3 units right. Next, let's move to this part, the 2, the a value, because after we translate it 3 units to the right, we're going to dilate it by a factor of 2. So vertically dilated by a factor of 2. And then the last piece here is this plus 1, which is vertically translated one unit. You could also say up 1 unit. So you can decide if you want to just use the signs of the numbers to indicate the direction, or if you'd like to actually state it's translated up 1 unit. Here's another example. We're going to let n be a function that is a transformation of another function m, such that n of x equals negative 4 times m of 2x. Let's describe the transformations of the function m that will result in the function n. Again, I want to start on the inside and work my way out. So this 2x, when it's in the parenthesis, it does the opposite of what you see. So when I see a 2, it's actually the reciprocal of 2, so 1 over 2 for the horizontal dilation. So in a sentence, we want to state that the function m is horizontally dilated by a factor of 1/2. Then let's look at the outside here. We have an a value of negative 4. Remember, for the dilation, it's the absolute value of negative 4. So we'll say it is vertically dilated by a factor of 4. And then that negative there in front, what that does for the negative value is it reflects it over the x-axis. For our next 2 examples, we're going to practice doing a transformation to a function. Here, I have a graph of y equals f of x, and it consists of 2 line segments and a semicircle, and it's shown for negative 3 less than or equal to x, less than or equal to 3. So the domain of the function f is all x values that are between negative 3 and positive 3. And we want to sketch the graph of g on the same axes below. So that should say below, where g of x equals f of x plus 3 minus 4. Just like we did with the words on the previous slide, we do want to start on the inside of the parentheses. And remember, whatever occurs in the parentheses will be the opposite of what it appears. So when we see an x plus 3, that is a horizontal translation of -3 units. So here that's going to be left 3, right? -3 in the horizontal direction would be left 3. And then the -4 there would be -4 in the vertical direction. So that would be -4 would be down 4. So what I'm going to do is kind of take key points, like this point right here, and I'm going to count left 3. So 1, 2, 3, and then down 1, 2, 3, 4. And there is my new point. Then we'll just grab all the other key points. I'm going to start right here. And again, go left, 1, 2, 3, down 1, 2, 3, 4. And we land there. And then I'm going to just do the other end of the semicircle right here. Left 3, down 4. And then I'm going to do this last point. Left 3, down 4. And then for the semicircle, it might be helpful to pick a point like in the middle. So maybe this point right here looks to be at like 1.5 and 2.5. So if I go left 3, so there's a half, 1.5, 2.5, 3.5, and then down 1, 2, 3, 4. It looks like the top of our circle will be right there. And here nothing is being dilated, so it looks like it's the same size and the same shape. We just moved it to a different spot. Here we're given the graph of some function h of x, and you can see that it has a hole at x equals 4 and consists of 3 line segments. We want to sketch the graph of h on the same axes, where k of x equals -h of 2x plus 1. Before we begin the transformation, let's list out what's going on. So I'm going to start inside my parentheses, and when I see a 2, remember that inside the parentheses is the opposite of what it appears. So here it's going to be horizontally dilated by a factor of 1/2. Next, let's worry about this negative value. The negative value there is going to be reflected over the x-axis. And then the last piece right here, we have a +1, which is vertically translated up 1. Now that we have this key information, let's take the key points in the diagram and let's follow these transformations in order. First, I'm going to start at this point right here, and it has an x value of -4. We need to horizontally dilate that by a factor of half. So you're going to take half of -4, and that moves the x value of the point to -2. Don't change the y yet. We're just changing the x here. And now we're going to go on to step 2, where we reflect that point over the x-axis. So it's going to move from 3 below the x-axis to 3 above. And then that point, we need to go up 1. So my ending point is going to end right here. These little points that I'm erasing were just kind of guiding me there. Let's take this point here and again take half of the x value. That has an x value of -2. Half of -2 is -1. So I'm going to move there. Then I'm going to reflect that over the x-axis and then translate that point up 1. So we end right there. Let's erase our guiding dots. And now we have our first segment of the new graph. Let's move on to this point right here. It's at a 0 for the x value, and when we take half of 0, it's still 0. So our x stays the same, but we have to reflect again over the x-axis. So 2 below becomes 2 above, and then translate up 1. So that gets me right there. I'm going to erase my guiding dot, and now I have the next segment of the graph. Let's find the next key point. I'm going to move over to this point right here, the hole. And the hole there has an x value of 4. We need half of 4, which is 2. So that moves me to right there. Then I need to mirror that over the x-axis and then move that up 1. So that puts our new hole right there. We'll erase our guiding dots there. And then I'm going to next do this end of the graph. So this point there, it has an x value of 6. Well, half of 6 is 3. So we'll move over here. Then we mirror over the x-axis. So from positive 4, it's going to move down to negative 4. Move it up 1, and there's my endpoint. And that gives us the next segment of our graph. And that looks good. The last thing that I need to do now is I do need to do the point that is the hole, or the other point on the hole. So this point right here has a x value of 4. Well, half of 4 is 2. So that moves me to right there where my hole is, and then I need to go reflect over the x-axis, so up here, and then translate 1 up. So that ends us right there. So that point, I'm going to make it yellow so that it matches my new graph. There we go. Now I'm going to skip around a little bit so that you can do the first half of your CYU. So now we're going to skip around a little bit. The next example in your notes, example 5, we're going to go over on day 2. We are going to skip over example 5. We'll come back to this on day 2. And I want you to move. So for now, just write down day 2 right here, and we'll come back to that one tomorrow. Move on to example 6. And this one gives us a table of values for a function p at selected values of x. And we have h of x, which is a transformation of the function p. You can see h of x equals 3 times p of 2x minus 1. And we want to find the following values. Find h of negative 1. Well, h of negative 1, if we go to our equation here, is going to be 3p of 2 times negative 1, and then subtract 1. So that's 3 times p of negative 2, subtract 1. We can go to our chart and find the p of negative 2 is equal to 1. So that's 3 times 1 minus 1. And when you do the subtraction there, that is going to be 2. So h of negative 1 equals 2. Let's try h of 2. For h of 2, we'll take 3p of 2x, so that's 2 times 2, and then minus 1. We want 3 times p of 4, subtract 1. You can find p of 4 from the table and see that's 3. So 3 times 3, subtract 1, would give us 9 minus 1, which is 8. Go ahead and try h of 0 on your own. Pause the video, and then when you hit play, I will have the solution for h of 0 posted. Here is your solution for h of 0. You should have gotten a negative 4. That'll be it for the day 1 portion of topic 1.12. We will finish the rest of the examples on day 2 of this lesson. Thanks for watching. Bye.